Okay, so good evening once again to all the masters in this session of functions in C programming. So today we are going to be talking about function in C, and I already sent to you people the program in the afternoon or in the morning. And so today we are just going to see what we can do. So the first question that we should be asking ourselves is that what is C? What is C function or functions in C? We talk about functions in C. What does that mean? It means that it's a block of codes that perform a specific task. A function in C is simply what? It's simply a block of code.
A block
Yes, it's a block of code
that performs
that performs what?
a specific task.
Yes, it's a block of code that performs a specific task. Specific task. This is all about functions. When you hear of a function, and so it actually helps us to divide a big program into smaller parts and making each of these parts of the program easier to write, to understand, and even to manage. Easier to write, to understand, and easy to manage. So that notwithstanding, we are going to talk about the types of functions in C. Types of functions in C. There's no need to writing all these things here. Even types of functions in C programming. And so we have two main types of functions. The first type of function that we have is actually the C library function. Okay, so we always call them library function. And here we take, for example, print f. We talk about scanf. Okay, we talk about what again? The square root. These are these are functions. These are functions that are already integrated in a C environment. And so we just need to use them. And then the second type of function that we have now is the user-defined function. User-defined function, which means that these are functions that the user has to define, and then it is a programmer that makes these functions. You write the function yourself to do something. So these are the two functions that we have. Now, why do we have function? Why function? Why do we have function? We have function because first, it make us to avoid repeating codes. What does that mean? It means that we write code once, and then we can just modify the code instead of repeating one thing over and over. Okay, and then equally make program easy to read. So they make program easy to read. Then the next one is that to make testing and debugging easier. That's where we have function, because we can easily debug, and then we can easily test our program when we have a function that we have written. And then it also divide our work among team members. Suppose that we have so many people that are going to be working on a project. We can equally divide our work, divide among a team, so that they should be able to work. Somebody will work one part, another person will work another part. Then we join the thing, and then all together we are going to combine it and then come out with a good function. So now the structure, the function has a structure of a C function. So this structure of a C function is always in this form. So here we have return type. Then here we have the name of of the function, and then bracket open and close, and inside the bracket here, we have parameter list. So I'm going to explain. Here, we're talking about return type. The return type is the same like the data type. That is the kind of data that our function has to return after performing a series of tasks. What kind of data type or what kind of result is it going to return? And this data type we are referring to, it can be an integer, it can be a float, okay? It can be double, and so on. And then the name of the function is very important, because when we write a function, we have to call in our main function. So we need to use a name, and it's good to use a name that reflects what we are doing, so that we should be able to call in our main function. Then parameter list actually are the values that we are going to pass in our function. That is the values that our function is going to have in order to carry out the operations upon. And so here, the parameters we are talking about, we also talk about the data type and the variable. So here we talk about the data type. Let me use one word of data type, and then the variable name. The variable name is very important. And then you have to separate it by comma and so on, if we have so many of them to pass here. So quickly, since we don't even first of all have enough autonomy, there's no light, so on, we are going to go briefly and just start doing some work. Then we explain the work as time goes on. Maybe I was a little bit fast, and now I will slow down because I want to start coding now. So we all know that if you have to use printf, and then we have to use something like scanf function in our program, we need to include this library, which is hash include standard input. And that is what we have to do first. And then here, this is the structure of our C program. This is the main function where our functions are supposed to be called. Okay, so here I'm going to talk about function declaration. Function declaration. So it's just like you want to use a variable, or you want to use yes, a variable, you declare it and then you use it in your program. So it also works for functions. Functions, we equally declare a variable, and then we declare the function, and then we use the function definition to really tell what the function is supposed to do. And afterward, we call the function. So the function definition is always, let me put it this way, always outside our main function. Outside our main function. You cannot declare your function here, because it's already a function, and this function is the main function. So you cannot declare your function here. That's one of the things that function will not accept in C, and I believe in other programming languages. And after function declaration, we talk about function definition, which is equally this is actually what the function is going to be doing. Okay, so we define what the function is going to do, the behavior of the function. And so it is equally outside, always outside of the main function. So we always put it outside of the main function. It's not inside the main function. This is the main function I'm referring to. So here, the first thing we have to do, we talk about, let me think there is this question that it always comes even in paper 2, GC question. They always talk about swap, function to swap two numbers. And they always tell you to swap by reference and to swap by value. I think that you have encountered that problem several times. So I want to use this opportunity and then just answer that question so that it can sort out some difficulties that someone might be facing out there. All right, so the first thing I'm going to do now is that I will just say that I want to write a function. I'm going to write a function to swap two numbers. So when the user enter two numbers, we'll be able to swap the numbers. Okay, and so our function declaration will be void swap. And then inside here, what are we going to have? We're going to have two numbers, the two numbers that we are going to swap. Remember, I'm talking about function to swap two numbers. Let's say A and B. So we have A maybe as 100 and then B maybe as 200. We want that at the end, we should be able to have this number swap. A will take the place of B and then B will take the place of A. So to do this, we have to go by value and by reference. And you have to take special note here because when you go by value, the values will not change. When you do swap of a function in C or even in other programming languages by value, that is called by value, and then called by reference, there are two different outputs you are going to see. Not to talk too much, I'm just going to illustrate and you're going to see how this is going to be done. So now this is our return type. From our function definition, we have return type. And then here we have swap as the name of our function. And in here, I want to start with pass by reference. To pass by reference, we can have, we use asterisk as or pointers. So this is my first number, which is acting like a pointer. And then the second number, which is B. Yes.
What are pointers?
Pointer is a kind of data types that use the memory address of another one its own value. I think that we have seen that even in when we were learning data types, so maybe I did not tell you that. So it is a type of data type that does not really store a value, but it stores a memory address as its own value. So when you declare a pointer, it's going to take the memory address where A is found, and it's going to keep the address of A. And then when you call it, it's going to refer to that memory address or that location where A is found. And then we access what is kept inside that A as its value. I want to be sure that it's a little bit clear now.
Yes, sir.
Okay. So
Meaning that it, meaning that it is not really changing the value that it's changing the memory where the values are located.
yes, for example, let me take for example, if I have A, let me suppose that the memory address where A is found, this is A, and the memory address where A is found, let me just put it below, that is 1101. This is address, okay? And then A is equals to 100. And this 100 now is actually the value. is a value. Now, when we declare a pointer, it is going to point to this address. So the pointer is going to store this address of A in the memory. So the memory, there's a particular address. Address is just a location where the values are found. So it's going to store the address, and then when we call now the function, we are going to access the address of where A is found, and then read the value of A, which is found in that memory location. And now it will be 100. Okay. But if we store only, if we use a variable, just A, in our memory, without using the address, you see that we will call by value. Imagine we are just calling this value. So what is going to be copied to us will be called to us. It will simply be this 100. But if we use the address, there's a possibility now to modify the content of what is found in that location to a different one, and then swapping will actually be possible. Let us just do it and run so that you can see. Maybe from there, you will better understand something. So this is our function declaration. And so here, I'm going to write the function. So we have void swap. I want to swap two numbers using pointers or using reference. So here I have my A and my B. Okay. Then I declare a certain temporal location, a certain temporal variable where I'm going to interchange or to be able to swap the numbers and successfully. So the first thing I'm going to do is this number or this variable will first of all take the value of A, okay, and then the value of A will be now assigned to B. So now when we do like this, the value of A, of that memory location where the value of A is found, will be assigned to this temporal value, so that there should be space now inside our A. And in that space where A is found, B will now be able to be assigned to that A. Are you seeing? And then we are going to take that B and then assign it to 10.
To that.
And then now you see that whatever value of A that was found inside tempora will be overwritten. And so swapping has taken place. This is by reference. Now inside our main function, we just need to call this function. Okay, call this function. So how do we call it? First of all, let us just assign some arbitrary numbers. Let us say x is equals to 100. Okay, then y is equals to 200. These are some values that we just declare because we don't want, we know that we can ask the user to enter numbers and so on. That one is, we have already passed that level. So we are interested with the function. So here, when the user, or we already have these two numbers, we have to call the function. But I want to bring a message so that we can be able to see what will happen when the functions are called. I will just say that original values, what is my x? So I will just say percentage d, or let me just say x equals percentage d, comma, y equals percentage d. This is actually no news. We are already used to this. So here I'm going to have x and y called. Okay. And then I'm going to call my function now. So here I say function call. To call the function, we just need to bring the name of the function. The name of the function here is swap. So I will just put swap, and then we have passed some parameters. We call these parameters or arguments inside this function. And so we pass two parameters, A and B. We also need to supply two parameters here, A and B. So here, X and Y will represent the two parameters A and B that we have passed in this other function. So here, I'm going to access the address. So I'm going to say ampersand X and then Y. Since we are now accessing the value at that position. After this, I'm just going to print our new values. So print F, say new values. New values X is equal to percentage D, then Y is equal to percentage D. Okay. Now I just call X and Y again. So this is all about the function, and we have to run it now and see what will happen. So let me run. If there are some errors, we'll correct. If there are no errors, it will run. So there's no error, and then our program has run, our function has run. So you see that original values is 100, 200. Now new values, what is this? 200, and this is
200.
100, which means that the swapping successfully took place. If you look at our program here, you see that our X is 100, our Y is 200. Now these are the initial values or the original values. New values, we have X to be 200, and then, so swapping took place. Now the question is, what about a function called by value? If you use call by value, what will really take place? What will happen? I will not explain
Yes,
much. Yes.
I want to ask that from the initial way you taught us how to write functions,
Mm-hmm.
it, us when we usually write like the void swap,
Mm-hmm.
and we, we usually just write everything on top before we write int main.
Mm-hmm.
If we write like that, there's no problem now.
There's no problem. There's no problem. But
Okay,
now here's a deal.
because
If you write this function, this one, all right, the function
yes,
definition here, you see that there will be no problem. But if I take this one, function declaration, and put here, I'll have trouble.
yes,
Let's
sir.
let's run and see. Okay, this one does not have problem. Eh? This is serious. But I'm sure that with some other environment, because this one is a little bit integrated or more advanced environment. But I want to believe that if you use maybe code block, it will not be really a problem.
Yes, sir.
Mm-hmm. Will not really be a problem. So it's always advisable that we should use our function declaration or function. Anyway, there is no problem. It works. It works. Even in other programming language, it works because we said it should be outside of the main function. It should be outside of the main function. So when we run this one, in other words, function declaration is not really obligatory. That's why it ignore it. It's not really obligatory. You see that it's running even without it now. I've
Yes,
removed the function declaration, but it's still running. But if I remove the function definition, there'll be problem. Let me carry down here. Let's run and see. Error has occurred. This is what I was talking about. Rather, you see,
Yes.
you see that we cannot run it, we cannot give it outside of this function, outside of the main function down here, because our program will be searching for swap as it's compiling from up. It will first of all encounter this one. As a compiler, it first of all encounter this before reaching here. So when it encounters, you can even see that there is a red wavy underline, already indicating that it is not seeing it. So it's supposed to see before reaching here, but it has not seen. That's why we add function definite declaration here, so that you should be able to see that it exists, it was declared. It's the same like using a variable that you have not declared. If I'm just using X without declaring it, you see that there will be an error in the program also. So the same thing happens for function. Thank you for that question. So now that the program will run without any problem. Okay, the class today is not easy. Only 4 people or 3 people are online. It's because of the blackout.
Excuse me, sir, I have another question.
Yes.
Excuse me, sir. When we usually write function, most of the time when we write voice, it means that we're writing a procedure.
Very good. I was about to go to that. Means that you already know the difference between a function and a procedure. A function must have a return type. Meanwhile, a procedure does
Yes,
not
sir.
have a return type. So when we have void, we are calling it
Caution.
function, but the real thing we are writing here is procedure.
Okay, sir. That I was wondering.
Yes, the real thing we are writing is procedure, because this one does not have any return type. You see, it did not return any value, did not return
Yes.
anything. But if we use something like factorial of a number,
Yeah, we use return
we use return.
for
In
the base.
fact, we are writing that it's a function. It's actually a function at that time. Okay, I think that with this definition is very, very important, or this introduction. I will not want us to stay too long since batteries are fast going out. And then equally, I want to write a one that is called by that function called by value, so that I can see this difference. It's very important. Okay.
Yes, sir. Always coming
So,
MCQs.
uh,
Yes.
It's always coming MCQs.
yeah, when it comes to MCQ this time around, you don't need to think twice, because you're going to see it here.
Yes.
You see that when it is called by reference, the values are actually going to be changed. But called by
Mm-hmm.
value, the values are the same. There's no change. So if I give you in an MCQ and I said, okay, what would be the output if I run this function called by value, and then I say x is equals to 100, y equals to 200. I now say, okay, in my multiple choice, one of the options is that x is equals to 100, y equals to 200. That's the same thing as here. Not so. That would be the answer.
Yes, sir.
That would be the answer. If you say that, okay, at the end, my x will be 200 and then my y will be 100, called by value, you are wrong. Okay, to do that, we just need to remove these stars. We just need to remove these stars. And then come here and then remove this address. Because that shows that we are calling by value and not by address. It's the same program. We just remove this. Now, this all. The program remains. You see that I have not changed anything in the program. I just removed by those one to make sure that we are not calling them by reference, but that we are calling by value.
Value.
Yes. So right now, I just run. Look at what happened. Is there any change?
Nothing has changed.
So if
No,
they
sir.
ask, you now that what's the difference between call by value and call by reference, it is equally a paper two question that always comes. They ask you then that give the difference between call by value and call by reference. Now you have seen even with your eyes. You're able to better explain. You see now that when we are calling by value, at the end, the swapping will be done on the values and the values will remain unchanged. You see? But when we call by reference, actually we are going to access the memory address of that value, and at the end there will be actual swapping that will take place between the values. So call by values, the values are not swapped. The values are the same. But call by reference, there is a difference in the swapping, or the numbers are swapped. That's all. And we have seen it
Thank you, sir.
implemented in
Excuse
this.
me, sir.
Sorry?
That is understood.
Excuse me, sir.
Yes, somebody needs help. I'm listening.
The, the when we're using call by reference, the FSN there was standing for the memory location now, sir.
What?
When we're using call by reference, the
Mhm.
FSN was
The
standing for the memory
No,
location.
the ampersand will stand. The ampersands to this one here.
So, what is the use of the stars beside the A and B?
Yes, let me explain.